All right, let's go to number 6. What did we get for number 6?
B.
So angle 4 is this angle. Remember, an angle is made up of two rays where their endpoints meet, and that's our vertex. That vertex always has to be the middle letter. So SVW. What's another way that I could write this angle?
WBS.
Good, WBS. Either way would work. Good. All right, number 7, what did we get?
B.
That's the wrong side of the paper.
B.
Okay, I'm sorry. What's our number 7?
B.
They are congruent. Good. So we from our definition of congruent angles, if the measures are equal, the angles are congruent. If the angles are straight, measures are equal. All right. Number 8, what did we get? C. Now, we'll investigate because those of you that said A, you're very, very close to your answer. So what was our setup? Was it 2G minus 2 plus 4G minus 9 equals 133, right?
Yeah.
And what do we get for G? So what does the question ask? So if you stopped at 24, you didn't fully answer the question. Actually, you just didn't even answer the question. You were about to answer it, but you didn't get there. So make sure you're always careful when you read the directions. Check that what you're answering is what they're actually asking. How did we know that we could set this up this way?
If you add both equations to the two, you can't speak.
It's all right. Gather your thoughts. I'll put you on the spot.
If you put the two angles are adjacent, and so they make up the bigger angle, and so it's adding.
Yeah. No, you got it. We've got two adjacent angles. What does that mean to be adjacent?
Share a side vertex.
Very good. They share that side of vertex. So if we have two adjacent angles, we can add up their measures, and that'll give me the measure of this big one here. So this guy is our first one, NRN. And this guy is our second one, NRT. That gives me the whole thing, MRT, which is 133. Now, you might sometimes want to put parentheses around to start off with, but you don't really need it because we're just adding. But sometimes later on in the year we'll have where you'll need to subtract it with different types of problems. So just be careful if you are subtracting an expression, put the parentheses, because what would we have to do if this was subtracting? We'd have to distribute that, yeah. Now, this one is not subtracting. Alright, Alright, and number 9, what did we get?
A.
Good, A. What do the angles have to be? What would their measures have to be? 45. Good. Now with this, keep in mind, all right triangles are not created equal. This is, that's a pretty close example of a 45 angle triangle. So this is called a 45-45-90 triangle. It actually has special properties that we'll be learning about in February or March. It's actually really exciting. I'm so looking forward to this unit. But anyway, just because it's a right triangle doesn't mean that the other angles have to be 45. I could have, let's say, 60 and 30, right? Or I could have, let's go, maybe this is, I don't know, what does that look like? This one looks like maybe 10, so we'll go with 10 and 80. How do we know that these are 10 and 80, 30 and 60, 45, 45? Come on. How many total degrees are there in a triangle? 180. So since this right angle is 90 degrees, that means there's only 90 degrees left for the other two, so these two have to be 90. Did you guys learn that in middle school or elementary school one time? I said it this morning that I wasn't sure if you guys had actually learned that. Well, now you know. They're 180 degrees in a vertex. All right. So again, we had here, we talked about how we can rename an angle. We talked about congruent means measures are equal. We talked about our angle addition postulate and 2 angles down there. On the front side here, we talked about our planes intersecting. If 2 planes do intersect, they intersect at that line, as you can see there. Again, kind of like that ceiling and the front wall. And we talked about opposite rays. Vertex, notice it's written, this is important to say. For D here, notice it's written as TS, not ST like that. Your vertex always comes first, and then your second letter indicates in which direction. So you'll notice they have the same vertex in order for it to be opposite rays. We recapped that you have to have at least 3 points to define a plane. That third point kind of establishes where in space it's standing. And what was our last one here? Oh, that to label a line, you just have to have 2 points on the line, and lines cannot be equal because there you don't have measures just like segments. Oh, there's one more down. I don't think we even actually talked about this. So it says if 2 lines are coplanar, which of the following must be true? You guys were correct. All points on the lines are coplanar. So you have to be careful with these types of problems. Because it says which of the following must be true. So A, B, and C could be true, but just because they are coplanar doesn't necessarily mean that they intersect. They don't have to be parallel. They might be parallel, they might intersect, we're not sure. But what they do have to be true is that all the points on the lines are coplanar. Because if the lines are in the same plane, then everything that's on the lines is the same plane. All right, any questions on those homework problems? Okay, let's go and take a look at your homework. Remember that he was on Blackboard. Ideally, we looked at our answers so we could be quicker with their questions. Now, there were, I think, a couple of mistakes we need to address. Letter B on number 7, so 7B, which did that say?
12.
Whoa. I fixed it on my computer. So 7B, it should be 12. Why is it 12 not 6? Yeah, it asks for the entire segment, SU. So we know that ST is 6. We found that value. The segment ST and the segment TU are congruent. So if one side 6, the other side 6. All right. The other mistake was somewhere. Let me see if I can remember which one it was. Number 10. When I solved, I got y equals 6, and then when I answered, it turned into a 4 magically. This should say y equals 6, which we'll see over here. Did you guys find any other mistakes? We'll talk about the last page in a moment. There's a couple on there where you might have a different answer. But, great. Did we have any questions on the first one? Okay.
So number 8, I didn't get like the possible coordinates.
Number 8? Yes, okay. Number 8 was like this one. Okay. It says on a number line, suppose point E has a coordinate of 3. You can see a little bit. Okay. Suppose E has a coordinate of 3. The measure of segment EG is 6, and the measure of segment EX is 12. So again, notice that these measures are equal. Is point G the midpoint of segment EX? And what are possible coordinates for GX? All right, so we go and draw a little number line to kind of help us out visually. It says E is at 3. So I've gone ahead and plotted 3 there. Now the measure of EG is 6. So if I go 6 more than 3, what do I get? 9, right? So there's an option. But could I go the other way on the number line? Right, just so the distance So the distance from here to here was 6. Could I have gone the other way? Yeah. If I went 6 the other way, then what would have been my coordinate instead of 9? -3. Yeah, so if I went 3 or 6 to the right, I would have gotten 9. If I went 6 to the left, I would have gotten 3. Okay, and then it says the measure of EX is 12. So again, if I start with E, and I go 12 to the right, I get 15. But again, I could have also gone 12 to the left. I always get worried that that means our class too. Alright, so if I would have gone 12 to the left, what would that have been the value of? -9. So it says, is point G the midpoint of EX? So if we went to the right both times, then we would have, yeah, G is the midpoint here. We have a measure of 6, a distance of 6. Remember, measure, distance, length, all the same thing. And another measure, distance, or length of 6. So here we would have G be the midpoint. But we could have gone to the left and had it be the and have G be the midpoint the other way, where we would have again 6 distance and 5. But what if I had gone to the right for one of them and to the left for the other? So maybe I went to the right for G, but I went to the left. Pretend that I'm still drawing far out here for X. Then G is not that midpoint, or vice versa. If I went to the left for G and to the right for X, then G would not be that midpoint. So it can be, but it doesn't necessarily have to be. And that's where our other possible coordinates come from, is that we could have gone to the left with it. Does that make more sense? Making you think outside the box. Now we talked about how we can't have a negative length or negative distance. So even though we're going negative on the number line, we don't have a negative distance or negative length. The number line is just telling us the location. That distance, that length is still 6. It's just in a different direction. All right. Other questions on the front side of what we see? Good so far? Okay. Oh yeah, I'm sorry. I don't think I realized that everything is scrolled out. I apologize. Oh, I really skipped a lot, didn't I? Okay. I'm sorry, did we have questions on any of these spots? 13. Okay. Ooh, yes, this is a good one too. Is it possible that the measure of PQ plus the measure of QR is less than the measure of PQ? All right. Now, we know from our segment addition postulate that if we have, let's say this is P, let's say this is Q, let's say this is R, that if we take our segments and add them together, we should get the whole thing. Now, there was a little disclaimer that we had to write for our segment addition postulate. What has to be true about these 3 points in order for that to hold true? They've got to be collinear, yeah. So you got to have them collinear in that order for that to hold true. Now, they didn't tell us that it was collinear, so we can't assume that it is. So I went ahead and investigated the different scenarios we could have. First, let's take a look at if it is collinear. So I've got 2 different scenarios here. So the first one, we've got P, Q, and R in that normal order. And they also didn't specify what order they're in. So let's say that we went with P, Q, and R in this order. If I add these together, is it possible for this length to be less than the entire length? No, it would be equal. Okay, so we know that this one, not going to work. All right, now let's say we messed with the order. Maybe instead of having it P, Q, R, we took R and put it over here. So that was another situation. So let's go P, Q, R. Alright, so we have PQ, this distance, plus QR, this distance. Is it possible for that to be less than just this piece right here? No. So even if we move R to the other side, even if we moved it way far over, we can't have it be less because we're adding the R. See how we're adding this piece plus more? Because with QR, that covers what was there, right? Now let's say maybe we changed it up. Maybe we did Q over here instead of R. And I'm throwing the markers all over the place. All right. That's good. So maybe we took Q to the left instead of R. So we'll keep R over here. Q here. All right. So again, PQ plus QR. Is that going to be less than just PR? No, because again, it's the same scenario as here. QR is going to cover that distance of PR. So we can't have that be less because it's already more than that. So, and we're adding it more. So those are our collinear possibilities. So collinear, at least with collinear, we can't have it less. So then you're like, all right, Ms. Margraf, let's go non-collinear. Let's see what happens then. All right, so let's say this is P. Let's say this is Q. Let's go with R here. PQ plus QR. Can that be less than PR? No. So this actually comes back to something you learned, I think it was 7th grade. Notice what type of shape does that make when we have this one. A triangle. And what do we know about the sides of a triangle? Let's see if I can get you to this. What do we know about the sides of a triangle? Come on.
The two, like, equal, or the second one.
So if we have a right triangle, diagram there, right? Does that sound familiar? Remember that? So if it's a right triangle, then the side squared equals the hypotenuse squared. Okay? So we don't necessarily have that hold true then that the sides themselves altogether equals that, but there's something even more general with triangles and their sides. The angles add up to 180, the angles do, but something different about the sides. Okay, yes, no, maybe so. Alright, so something you learned way back when, I think it was middle school, not elementary school, is that if I take any two of my sides of a triangle, when you add them up, they have to be bigger than the third side. Remember learning that? Any two sides, when you add them, they have to be bigger than the third side. Which, if you think about it, that makes sense, because let's say that I had this, even if we laid it flat, and say this is my next side. Even if we laid it flat, if I have something the same length, it's just going to be that line on top of the line, right? But if I have something longer, then I can start creating that space in between. So let's say, well, just let me move this. Not the way I want to, maybe? Okay. So let's say we just slightly adjust it. So we need the blue and the green to be larger than the red for there to actually be a triangle. Because when they're the same, then it's just going to be a line on top of the line. If it's shorter, then you just have a short segment on top of the longer, or underneath the longer segment. So in order to actually get space in there, we need it to be a little bit longer. So let's make this blue a little bit longer. And then, now is when we can start creating that triangle. So any two sides of a triangle added together has to be bigger than the third. So that's how we can say with confidence that no matter what type of triangle it makes here, we still wouldn't have that the sum is less. The sum of the sides must be greater. That's one of our things with triangles we've learned before. So that's why even with non-collinear, that third side has to be bigger than those other two. Pretty good combo. Other questions with that, or any of these on the bottom side? That's a good one. Okay, those are good thought-provoking ones to. All right. You'll notice that my P is much more smushed together than yours. When I first did the key, I quickly recognized you need more space, so yours is the nice spaced out version. Mine's the smush version. So same problems, just you guys had more space to do your work. And again, I know we did some of these in class, but do we have questions on 19 through 24? Oh, did I lose 14?
14 on the other three.
14 through 18.
Those bottom ones? Questions on those ones? Sorry, I confused you. It's on the back side of your pages. Good with this? Okay. Now I'll go to my back side here. So 17 is angle GXF. Notice congruent notation, because they're just angles. Notice number 15, there's an equal sign and there's a measure that goes with it. And number 18 was 30 degrees and 80 degrees. I'm sorry, what's that? You're good. Are we good in mind? Alright, so take a look at 19 through 24. Do we have questions on those? I like 22 through 24 made you work on your vocab sign. I like 21 because it's pizza. You guys knew there's 360 degrees in a circle, right? Okay, good. You learn a little bit of geometry without realizing you're learning geometry. But sometimes I forget what exactly you learned. Because it's been a while since I was in middle school. Just a little while. Not like 50 years. Alright, take a look at those ones. I think this might correspond to your next page. So we have questions on these. Yes? 30? Alright, angle ABC.
How would you solve it?
Okay, so angle ABC and EBF are pair of vertical angles. So we're not using this picture, right? It says to use that just for 20 and 29. Okay. So they are a pair of vertical angles. So I'm going to go and draw a picture. So let's go A, B, C, and EBF. EBF. All right, so these are vertical angles. Now, before we go any further, what do we know about vertical angles? Good, they're congruent, their measures are equal. And the vertical angles theorem tells me my vertical angles are congruent. All right, so it says the measure of angle ABC is 3x plus 8. And the measure of angle EBF is 2x plus 48. What are they? Okay, well, since our vertical angles are congruent, so I could even make that statement. Angle ABC is congruent to angle EBF. That allows me to turn it into measure of angle ABC equal to the measure of angle EBF. What allows me to convert that there? What did we learn last class that allowed me to go from congruent to equals? Not vertical angles here, that allows me to say that they're equal or they're congruent.
Okay, if their measures are the same, then they're congruent. If they're congruent,
Good, good, good. Do you remember what the title of that was? Was it a postulate? Was it their definition? Good. So the definition of congruent angles allows me to go back and forth. If it was segments, the definition of congruent segments. Good. Okay, so then what we can do with this is we can go and take our expressions. We know that our measure of angle ABC was 3x plus 8. And our measure of angle EBF was 2x plus 40. And then solving from there. Let's see, 30 my works up here. So when you solve, you get x equal to 40. And then when you substitute it back in, you get 128. Look at that. Yes. 29? All right, so 29 we have the measure of angle COD given to us, and that was 8x plus 13. And then we have the measure of angle BOC given to us, and that's 3x minus 10. And then the measure of angle BOD, so the big whole hunkin' thing, is 12x minus 6. Now, what do I know about these angles, those three angles relationship? What can I say? Tell me anything, Kim.
They're adjacent.
They're adjacent. Good. And if they're adjacent angles, and we have these two pieces, and we have the third piece, what can I do with that? I got the little pieces, and I've got something for the whole thing. What can I do with that?
Find the measured angles.
How do I find those angles, and what do I have to do to set it up?
You do the measure of COD plus the measure of BOC, and you set that equal to the measure of BOD.
Very good, very good. So we've got this measure and this one. We know if we add them together, like Sam said, then we can set that equal to the whole thing. So those pieces add up gives us the whole thing. And again, that's when our angles are adjacent. So then we've got our setup 8x plus 13 plus, that's this guy, plus this one next to him, 3x minus 10, this guy, equals the whole thing. Since they make up this angle, we can set them equal to that whole thing. 12x minus 6. Does that make sense to set up there? So then when we do that, we get x equal to 9, but then asked just for x, they wanted the angle. So I'll start with that. Other questions on these ones? 31. Yes? 30? This is the one that we'll ask about. So vertical angles, we know they're congruent. So since they're congruent, we can take their measures and set them equal to each other. When you solve, you should get x equal to 40, and then plug it back in. Yes?
So why is there like an E equals 90?
Why is there an e equals 90?
Yeah, it's
Where is this?
It's under.
Well, I mean, it's not an E, it's like a.
Oh! So this is, just like, what is E? So this is it's actually called a sigma.
Yeah,
It's sigma notation. This represents the sum. So what I was saying is complementary means the sum is 90 degrees. If you add them, you get 90 degrees. That was just me defining complementary. That has nothing to do with the answer for this guy.
You don't even need.
Oh,
I'm messing with you.
okay.
The answer is here as 128. All right. Okay. Sorry. So this means the sum. You get to do more of that in algebra too. You actually get to do like sequences and series where you have like n equal to 1 going up to 10 of the sequence. It's like 5 times. I think that's 2 to the n minus 1, something like that.
We did that.
You do that in algebra too. You done that before? Ooh, good. You do like that. So you've seen this thingamabob.
Well, we did a lot of statistics like on the.
Oh yeah, where you did like mean, you add them up, divide by 2. Yeah, so that by itself means the same thing. You add the numbers up together. So what this is saying is you find each individual term and add it up together. Okay. All right, other questions on up to 31? I'm sorry, I'm really very off with my Greek letters. It's all Greek to me. All right. We've got 32 through 35. So we have questions on those. Picture was very helpful. Yes?
37 to 39.
We're not going to go there yet. Right now, just 32 through 35. We have questions.
Yeah.
I mean, it will. Am I?
The 34 to 24.
24. So we get x equal to 24. You set it up as the whole thing, 3x minus 12 equals 2 times 30, or 30 plus 30. And so we get x equal to 24, so then your angle is 6.
When you're doing like 34, instead of multiplying that side by 2, do you multiply the other one by 1 half?
Yeah.
I did that by myself.
Well, let's do it then. All right, so for 34, they told us that QX bisects. And what does bisect mean if we have an angle bisect? Good. It cuts that angle in half, so we've got 2 congruent halves. So I can then state that angle PQS is congruent to angle SQR. And by definition of congruent angles, I can then say I know their measures are equal. I don't expect you to write this out each time. I'm just going to keep repeating it until you guys remember it. Alright, so if I have my measures are equal, for number 34, they told us that PQS was indeed 30. So we could go ahead and make the conclusion that that's 30. Laura, right? No. Laura? Yes? No? I think Laura sits there in the other class. Shannon. Okay. Shannon. So Shannon said, instead of saying this whole angle is equal to twice one of them, could we do the whole angle is equal to, or half of the angle is equal to 1? And you can. So let's go ahead and set that up. So we want half of the entire angle is equal to just one of those. Because since they're equal, one of them would just be half. Angle PQS. Alright, so 1 half times, what was my PQR? 3x minus 12 equals, and PQS is 30. Alright, so Shannon, did you distribute that 1 half, or did you multiply to get rid of it?
I distribute.
Okay, then we will distribute. So I have 3 halves, x minus 6 equals 30. Add my 6, I get 3 halves x equals 36. Alright, so I want to get rid of this 3 halves. You can do it in 2 steps or in 1. I want to get rid of the entire thing, so I can multiply by the reciprocal. If you want to do it 2 steps, you can first multiply by 2 to get rid of the bottom, and divide by 3. So I'm going to go ahead and just multiply by the whole thing, the reciprocal. Alright. So my 2's reduced, my 3's reduced. So I have just 1x, or x. And here, same thing as 36 over 1. So you could go ahead and multiply the tops and divide by 3. Sometimes, I mean, that will always work, but sometimes the numbers start to get really big, and it's harder and harder to work with. So you gotta work smarter, not harder. Can I reduce 36 and 3? Yeah, what's 36 divided by 3?
12.
And 3 divided by 3 is 1. So now I have 12 times 2 is 24. 1 times 1 is 1, so it's just 24. Does that make sense? That's okay. And you'll want to get, used to multiplying large numbers and fractions and simplifying like that. Look for ways that you can reduce it before multiplying the big numbers out, because you won't have a calculations like that. All right, other questions on 32 through 35. Okay. So now let's take a look at this next chunk. 36 through 39. Alright, so 37 and 39, I technically use something that you might not have known. So we said this earlier, but how many degrees are there in a triangle? 180. So for 37 and 39, to arrive at my conclusion, I used that factor. So I apologize. I probably should not have used it since we didn't formally state it. Now that we've stated it, we can use it. But I'll explain how I got yes for 37 and 39. So it says angle ADB and CDB are complementary. So ADB and CDB. So the ones next to each other are complementary. Now, again, just because they're right angles, or right triangles, doesn't mean that these are 45 apiece. We don't know that to be true. In fact, I could redraw this picture where it's clearly not 45 degrees. Right? So, if you were thinking, oh, well, 45 and 45 is 90, it's definitely complementary, that actually wouldn't be true for all cases, because we don't know what those are. But with the knowledge that the triangles have 180 degrees in them, we can conclude that they're complementary. And here's how we do. So the information that the diagram presented us with was that this angle and this angle are congruent, right? And that this one, what does this notation mean? Right angle, okay. Now, can I determine what this is? What type of angle that is? What is that? Also right angle. How do I know that to be true? Yes, it looks like this.
Because it's congruent with angle DBC and angle DBC.
So how did we know it was congruent? Because they didn't tell us, did they? It looks congruent. You gotta be careful because looks can kill. No, you gotta be careful because pictures aren't always drawn to scale. Okay.
Well, they have like a little circle to let me know which one side it is.
Well, so let me maybe zoom in here. We had this given to us, right? But did we have that given to us? No. So how do I know that I can make this? Lucy?
Because in order for that mark on the right to be an angle, that because you want to be straight, and you're straight.
So let's roll with that. Do you agree that this is a line? And do you agree that these two angles are adjacent? So they're adjacent angles. What else might they be called? We know they're supplementary, but why are they supplementary? What specifically are they?
Horizontal.
Starts with an L. Linear pairs, right? Linear pairs are when we have two angles, two adjacent angles, whose non-common sides form opposite rays. So basically adjacent angles that make that line. You agree we have adjacent angles that make that line? Now what do we know about all linear pairs? What are they? Supplementary. And so because linear pairs are supplementary, if this one was 90 and this adds up to be 180, this has to also be 90, right? Now, we also know that perpendicular lines meet at 4 right angles. So but that is why. It's because those perpendicular lines will make this 290 opposite. Okay. Why did I travel down that road? Oh, okay, so the information they gave to us was these two are congruent, that one's 90, and from there we can conclude this one's also 90, right? But they're wondering, here's all the markers. They're wondering, is this guy and this guy complementary? All right, so let's first take a look at what we do know are complementary. So this is where I used the knowledge of 180 degrees in the triangle. Like we said, if this is 90 degrees, how much do these two have to add up to be? 90, right? Because if there's 180 in a triangle, 90 is already accounted for, there's 90 left. So from here, we can go ahead and state that angle BAD plus, let's just go this way. All right, angle BAD and angle, this guy, ADB, are complementary. Do you agree with me there? That this angle and this angle are complementary? Because they have to add up to be 90, right? All right, so let's take it from there. If they are complementary, then that means that the measure of angle BAD plus the measure of angle ADB equals what? 90. Now how did we know that? Yeah, complementary angles, the definition says their measures have to be 90. All right, great. Now we're going to take a little side note. They gave to us that this angle and this angle are congruent. So right now we know these are complementary, but we know these are congruent still, right? So those are complementary. So let's go ahead and write out what we know here. So angle BAD is congruent to angle CDB. Do you agree with me there from the picture that these two are congruent? Now, if they are congruent, what can I say about their measures? The measures are equal. Measure C. Okay. Well, look. The measure of BAD is the same thing as the measure of CDB. So I can just substitute that into my equation. We don't know what that is. Maybe it's 30, but if this is 30, so is that. So I can substitute that in. It's the same thing. So if I rewrite that, let's go over here. Then I'd have the measure of angle CDB plus the measure of angle ADB equals 90, right? I just simply replaced angle bad with angle good. Okay. Questions so far on what we're doing? We're just kind of reasoning through it. Yes, please. Not until we finish this. All right. So are we good here, though? All right. So now, if they add it to be 90, now we're working with two different angles than we had before. What does that mean if they add it to be 90? They're complementary, right? So can I then say angle CDB and angle, that looks too much like plus, I'll just say angle. And angle ADB are complementary. Do you agree with me there? Yeah. We just showed that their measures added to be 90, so it must mean that they're complementary. Well, what were they asking? Angle ADB and CDB are complementary. So that is how we're able to show that they actually are complementary. What we just did here was an informal proof, where we reasoned through, we took what we knew about definition of complementary angles. We took what we knew about measures and angles being congruent and equal. We took what we knew about substituting, right, from algebra, substitution. And we took what we knew about complementary angles to arrive at that conclusion. Now, again, I apologize because in order to do this, you had to first start off with the fact that these add up to be 90, thus meaning the entire triangle is 180 degrees. So I kind of used stuff that you might not have known yet. So I apologize for that. If you did not know that information, then you wouldn't have had any other way to arrive at this conclusion. Okay. So 37 and 39 are similar in that regard through using kind of that material. Questions on this chunk then? Okay. So then let's go ahead and take a look at 40. I think that's on your back side. Do we have questions on 40? A, we got x equal to 8, B was 55 to 35, and C, you substituted it into your complementary definition. All right, and then we had factoring, right? Let's see how you guys did with this. I'll trust you guys. What did we get for our answer for 41? X minus 15, x plus 2. Do we agree?
Yes.
Did anyone make the mistake I did when I first saw this and said, oh, x minus 10, x minus 3? You guys are all that good. So just make sure that it's good when you do factoring. Do a quick mental check. Do these multiply to give me that negative 30? Yep. If I added this, it give me that negative 13. Yes. All right. 42. Was I able to use that shortcut? No. We got to do good old-fashioned factoring by using that regrouping method. And again, in here, you have to use that regrouping method unless we've got that nice shortcut. No siding and dividing in here because that will not work with every single problem, and it's not mathematically equivalent. Alright, so make sure you are doing that regrouping method. If you don't do it, then you will lose points for not doing regrouping, especially when the instructions remind you to. So if you're still struggling with regrouping, make sure you come see me. We can go over that. It's pretty simple. Alright, what did we get for this? I heard a 2x and then minus 1. Okay.
3x plus 7.
3x plus 7. Do you have any questions on that one? Alright, number 43. If I could have one volunteer give me the answer. Lucy.
2x minus 4x minus
2x minus 4x minus 3. Do we agree?
No.
Why not? We almost agree, but what holds us back on it?
You can simplify the 2x minus 4 more.
Yeah. So what's the very first thing we should always check for? A GCF. Now, if you forgot the GCF in the beginning, you can just do it at the end. So if you forgot to factor out that 2, look here. Can I factor something out here? A 2. What do you know? So this will be out. So Lucy, if you forget it, you're good. Just look at the end. Always check your factors to make sure there's nothing more that can come out. Because if there's something more, that means you just forgot the GCF. Alright, and then I kind of covered up number 44. What was our... I think there was a 5x, 7x plus 2. Do we agree with those? Any questions on our factoring? Okay, so again, always look for that GCF. If you can, why could we do the shortcut on 41 but not on 42 and not on 44? Go ahead, Jay. What did you say? Good mathematical word too. We have the coefficient in front. So for 41, my coefficient's 1, you can use a shortcut. But anytime it's anything else, you cannot use it. Questions on that? Okay. We're going to go ahead and transition to the quiz next. It's a short quiz, only 15 minutes, and then we'll come back together for a little bit more review.